Hello and welcome to part 7 of module 17 in our C language series. In today's session, we're going to focus on searching a binary tree as well as deletion of a node in a tree. Let's start with searching a binary tree. Now, this is pretty easy to implement. Why? Because all we need to do is return a pointer to the node that contains the value we're looking for, essentially the key, or we return a null if the value we're looking for or the key is not found in the tree. Right? So let's now go ahead and modify the code we wrote earlier. For that, we need to go to code blocks and we can use the same file we used in the last session. Just click on recent files and open the file btree.c. Now, the first thing we need to do is to declare the function. So we can do that here after this last declaration. Let's put in there struct tree star. Search tree is going to be the name of the function, and that's going to take in parameters struct tree star root and char key, which will be the value that we will obtain from the user. Right? Now that we've declared the function, we need to call it, but remember this function is returning a pointer to the structure of tree type, so we need a variable to catch the return value. We can declare that here and say struct tree star search result. That's what I'm going to call it. You can call it whatever you like. And now within the main function, that is just before this exit statement, we can just put in a printf first \n, which is optional, and then ask the user for the character to search for, right? So printf enter character to search for, and then scanf %c, comma, and we're using the same variable that we already have, which is input letter, right? f-flash stdin. Once we have the input from the user, we can call the function. Remember again, this function is returning a value, so we'll use search result to catch that value. Search result equal to, and then call the function search tree, passing in arguments root and input letter. Right? After the function is called, we can check search result to see if it's null or not. So if search result is not null, which means we have found the value we're looking for, printf %c found in tree and comma, we can use search result now, arrow info. Else printf %c not found in tree, in which case we will use input letter. Right? That's all. Now we need to write the function itself. So you can put in the function anywhere. I'm just going to put it last here. So this will be struct tree star search tree, and that will take in the parameters struct tree star rt and char key. And within this function, we'll first check if root is null. So if not rt, which means root is null, then return root. Otherwise, we'll have a while loop. Condition will be while rt info not equal to key. Right, so this loop will run or execute as long as root info is not equal to the value we are searching for. Within this loop, we check if key is less than RT info, which means we've now got to look only on the left of the root, right? So if key less than RT info, then RT equal to RT left, else RT equal to RT right. And then of course that loop will continue checking for whether RT info is equal to the key or not. Now we could encounter a null, so we'll put in an if statement here. Then we say if RT equal to null, then break. Right, so there could be two instances where this while loop will be exited. One is if RT is null, the other is if RT info is equal to the key or the character we are looking for. Right, and down here we just say return RT. And that's all. Right, so let's run this now and see the results. First, create the tree. That's our tree. Let's enter a character to search for. Let's say F found in the tree. Right, you can run this again, looking for a character that is not in the tree. So let's create the tree again. And let's look for Z not found in tree, right? So you can come up with your own logic for this program as long as you achieve the outcome we are looking for, right? Let's move on now to the next part of our session, which is deleting a node. So deleting a node, unfortunately, is not as simple as searching. Why? Because first of all, we could be deleting a node that may be the root, or we could be deleting a node that could be the left node or the right node. And the node that we are deleting, be the root, the left node, or the right node, could have 0, 1, or 2 subtrees attached to it. We cannot afford to lose those subtrees. The best way to understand deletion of a node is, of course, to write code. So modify the code to allow for deletion of a node. But before we get down to writing the code, let's look at the visuals of some of the situations we have to take care of. So first of all, let's say we have a situation like this. That's our root. And we're deleting the root with just one node in the tree. Now this would be pretty simple. We don't have to take care of any subtrees. We would just assign a null to the root and we're done. Essentially, at the end of it, we would have no tree. Let's take another situation, something like this. So again, we have our root. Left subtree has a null there. Right subtree has got some nodes, right? And of course, we have our terminal nodes, as you can see there. Now we are deleting the root, but the left subtree is none. So what we would do is we would essentially have to make this one the new root, right? Before, of course, we delete this. So we'll assign this to the root and then delete this. Or you can, in other words, say that we will save this particular node and then essentially free this root or this pointer, right? We could have another situation where we have something like this. That's our root, left subtree, right subtree, and of course the terminal nodes. We're deleting the root, but the right subtree is none. Of course, we do have a left subtree that we need to preserve. So again, just as we saw in the previous situation, we would save this particular node before, of course, releasing this pointer, right? So essentially, B would now be our new root, right? Coming to another situation where we have something like this. So now we have the root, the left subtree, and we have the right subtree, and of course our terminal nodes. Now we want to delete the root, but we have both subtrees that we need to preserve. So what would we do? One idea would be that we could take this entire subtree and attach it to this node before, of course, releasing that root, right? So that would be something like this. This is our tree before deletion. So our root, left subtree, right subtree. Deleting the root again with both subtrees present. So what we would do is we would take this entire left subtree and attach it here, right? And then of course we could save this particular node before releasing the root. So now we would have a new root, and of course our left subtree and our right subtree, right? So what's important to remember is that when there is a subtree involved, we have to preserve that subtree. We cannot lose the entire tree. Now, keeping this in mind, let's write the code. So let's go back to code blocks, the same file, and right up here, just after we declare that search tree function, you can put in the declaration for delete tree. So struct tree star del tree will be the name of the function. Again, this function returning a pointer to the structure of tree type, and we put in the parameters that this function will take. So struct tree star root and char key, which will be the value we're looking for in order to delete that node, right? Once that is done, the next step, of course, is within main, where we will ask the user which character they want to delete, right? So here, just after this particular statement, right, we can say printf enter character to delete, keeping it simple, and then scanf %c, comma, again use input letter. Okay, and of course flash stdin. Once we have the character that we need to delete, we can proceed to call that function, right? So again, we can use search result, the same variable that we had earlier, equal to, and we call del tree, passing in the arguments root and input letter. Okay, now after we've done the deletion, you would want to see that the node is deleted, right? So we can print out the tree. For that, we put in a statement here, first root equal to search result, right? And then call in order, passing in root. Okay, so I hope that's clear. And then of course printf \n. Okay, so we've asked the user for the character to delete, we're getting the return value in search result, we assign search result, which will essentially be a pointer to root, and then call in order passing in root. Okay, now let's go ahead and write the delete function itself. So down here, we say struct tree star del tree and pass in struct tree star root and char key. Within this function, we need pointer variables now, right? And we'll see why shortly. So first of all, just put in a statement, struct tree star ptr1 and star ptr2. Now the first thing we'll do is we'll check if rt_info is equal to key. That is the value we're looking for, and the node we want to delete. Then within this if block, we say if rt left is equal to rt right, which will happen, of course, if both these are null. Then we free root, because this means we have just one node, and return null. Otherwise, else if rt left is equal to null, which means we do not have the left subtree, then printf, we don't need a printf actually, or you could have it just for your reference stating that left subtree is null. So we can say left subtree is null, and now we'll use ptr equal to rt right. So we are saving that node, right, or that pointer, and then we free the root. Okay, and we return ptr1. So this should essentially be ptr1, right? We return that pointer. Okay, so now we're taking care of where the left subtree is null. The next situation could be else if right subtree is null, right? So if rt right is equal to null, then printf right subtree is null. This of course is just for your reference. And then ptr1 equal to rt left, right? So we are preserving the left subtree, free rt and return ptr1. Hope you're with me so far. Else, which means now both subtrees are present. So here we have ptr2 equal to rt right and ptr1 also equal to rt right. You'll see why we are assigning, rt right to both of these shortly. Let me say here, while ptr1 left is not equal to null. So now you know why we're assigning rt right to both of these. This one is going to traverse the tree until we encounter a null where we can attach that subtree, right? So while ptr1 left, we say ptr1 equal to ptr1 left. Right? So this will go down the tree until we encounter a null. That's just that one statement for that while loop. And then we say ptr1 left equal to root left, right? So rt left, correct? And then free rt and return ptr2. Okay, so I hope you understood this. This one will be the new root. Okay, and we will have that subtree attached to its terminal node. Now, after this, remember, this is for if rt_info is equal to key, right? Now, if it is not, then after this, we can say if rt_info is less than key, right? Then we've got to say rt_right equal to del tree. We're calling that function recursively now, passing in rt_right and the key. Else, which means rt_info is greater than key, then rt left equal to del tree and passing in rt left and the key. Right, so I hope you understood this part. Like I said earlier, this particular bracket or this block of code is for if rt_info is equal to key. So we found the match. Then of course we are checking if there is just one node in the tree, or if we have a left subtree which is null, or we have a right subtree which is null, or we have both subtrees, right? Otherwise, if we've not found a match, then we need to traverse the tree until we find the match. Okay? And then of course we return rt. Okay? So I hope this is clear. In terms of the logic, you can use any logic that you like, provided it gives you the outcome you want. Okay, so now let's run this and see if it works. Let's say D, E, G, B, F, C, E. Okay, so that's our tree. Enter character to search for. Let's try to delete the root. Enter character to delete D. And you can see now that we've printed out the tree without that root. So we've preserved the subtree, right? Or rather, we've preserved the rest of the tree after deleting the root. Okay, so you can play around with this program. You can put in different trees, right? And then see how this works. Now moving on. The degenerate tree. So what exactly is a degenerate tree? Normally, if we supply data that is random, we are more likely to get a balanced tree. So how does a degenerate tree come about? This happens if we provide information that is already sorted. It's possible to readjust this tree to make it more balanced, but that requires advanced programming algorithms beyond the scope of this course. But just for you to understand, this is what a degenerate tree would look like. Okay. Now, coming to our conclusion on binary trees, Binary trees have worst case log n to the base 2 comparisons in searching, very similar or the same rather as the binary search we've spoken about in an earlier session. They're better than linked lists because of course they cut down the search time, as we have seen in our sessions on binary trees. Therefore, they are very efficient for database management programs. This ends our session for today as well as module 17. In the next session, we talk about sparse arrays. Till then, take care, stay safe. Bye.